Alright, we're going to start with number 13. On number 13, Parker, which side would you start on number 13, buddy? This is some homework from last night. Left, okay, I agree with you on the left. Why would we not start on the right? It's pretty much already in sine and cosine, and those are your basics, so you cannot really break those down. So I'm going to start with number 13. Hey, Joe. We need to take a test before you leave today, okay? Secant. How could I break secant down, Nick? 1 over cosine. Very good. Harrison, how could I break tangent down? Sine over cosine. Very good. Now, looking at this, I go back to my toolkit. Zach, which of these strategies might I use now? Finding a common denominator. Why do I know I need to find a common denominator? Emma here. Fractions, and I'm subtracting. Very good. Now look at this. Do I have a common denominator, class? Yes, I do. I do have a common denominator, so it's cosine theta. 1 minus sine theta. Well, look, is that what I wanted to prove? So I'm done with the problem. So I put that it is equal to that, and that is my proof. Alright, number 14. Tyler, what side did you choose to start on this one?
The right side.
The right side. I will go with that. Now, if you start on one side and don't get anywhere with it, can you erase and start over? Yeah, so sometimes it's like a mystery. You're being a math detective. You're trying to figure out to prove it. So I'm going to start here too. How can I break tangent down on Kylie? Very good. Sine theta over cosine theta. How can I break cotangent down, Matthew? Cosine theta over sine theta. Very good. Now I have it broken down like that. Jaden, go back to my toolkit. Which strategy would I use next? A common denominator, yes. What would be my common denominator, Alan, between cosine theta and sine theta? Very good. I cannot make one become another or the other become the other, so therefore I got to settle for both of them. So my common denominator would be cosine theta sine theta plus. Now let's look here. What is missing from this denominator that I got down here? Sine. So if I multiply this denominator by sine, sine times sine is sine squared. Very good. Okay, what's missing here? Cosine. Alright, so I'm going to say cosine times cosine is very good. Now I'm going to write it as sine squared theta plus cosine squared theta over cosine theta sine theta. Now, looking at that, Abigail, what stands out to you there, hon?
The sine squared plus cosine.
Very good. That's the Pythagorean identity. Class, what's sine squared plus cosine squared equal to? 1. Very good. Now, I look at where I'm at. I've got it broken down to cosine and sine. I look up here. I want secant theta, cosecant theta. Can I rewrite that to equal that? Yes, because 1 over cosine is what? Secant. What is 1 over sine? Very good, and that is you have completed the proof for that problem. All right, let's look at, are there any questions on 13 or 14? This is from your homework. Oh, I love 15. Let's look at 15. This is a harder one. Friendly, which side looks more complicated? Left. I would start with the left, okay? In the left side, I have adding fractions. So I must have a what? Common denominator. What would be my common denominator between 1 minus cosine theta and 1 plus cosine theta, Gracie?
1 minus cosine theta.
Very good. I will settle for both of them. So I'm going to write that 1 minus cosine theta times 1 plus cosine theta plus 1 minus cosine theta, 1 plus cosine theta. Okay, here I had this one, but this was missing. So if I multiply the denominator by 1 plus cosine, I got to multiply the numerator. So now I'm going to have sine theta times 1 plus cosine theta. Here I multiply the denominator by 1 minus. I'm going to multiply the numerator. Now guys, I'm going to tell you something. When you get to this, I do not normally FOIL this out on bottom. I only do that at the end if I need to continue reduce. So that's my last thing. If I need to in the end, I will. But right now, that's not my main objective. Does that make sense? I'm going to work with the numerator right now, okay? So sine theta times 1 is sine theta. Sine times cosine is sine theta cosine theta. Sine theta times 1 is plus sine theta. Positive sine theta times negative cosine is negative sine theta cosine theta. Let's stop right there. I want to make sure we understand that. Okay, so I multiplied sine theta times 1 is sine theta. Positive times a positive is a positive. Sine times 1 is a positive. Sine times negative is this, negative sine theta cosine theta. So I'm going to ask you a couple questions. I need a hand signal. Do you understand why I multiplied the numerator the way I did? Hand signal. Okay, very good. Next question. Do you understand, and I'm going to need a hand signal on this, how I got the numerator now? Do you understand that? Parker, how do you feel? Okay, now what I'm going to do is draw all that all over this right here. Now I'm going to try to clean the numerator up first. I got this, and this goes out. Do you understand why those cancel out? We good on that part? Okay. Now, what's sine theta plus sine theta? 2 sine theta, okay? 2 sine theta. Now at this point, I look. I go, ooh. There ain't much I can else do with this right now. And I still ain't proved it's 2 cosecant theta. This is where you would make a judgment call. Should I FOIL that out and see if I can do something with that? Yes. And you're going to see that that's going to give you 1 minus cosine squared, isn't it? Which is going to be one of those identities. So that's what's going to happen here in just a second. I'm going to, let me see here. I'm running out of room. I'm going to do this on notebook paper in a minute. One times 1 is 1, plus cosine theta minus cosine theta minus cosine squared theta. You see that? Take a moment to look at that. And this is the only thing on this test. Like, we're practicing it today, tomorrow, Friday, Monday, test Tuesday. You got me? Like, I've already thrown the hard. This is one of the hardest problems in the unit right here, okay? All right. It's better than inverse trig. It's better. I love this right here. All right. So you see why that's 1 minus cosine squared. So what I'm going to do, I'm going to run out of room. 2 sine theta. I'm going to put sine squared in front of, instead of putting 1 minus cosine squared, I put sine squared. Now on your paper, you might want to do this. So if you want to review, hold on. Let's just do this because I don't want you to get confused. Okay. So after that step, I get 2 sine theta over 1 minus cosine squared theta. 2 sine theta, I can replace that with sine squared theta. Now, could you cancel something out here? I take that sine out. I had 2 there, so I leave what down here? 1. So I got 2 over sine theta. Now, I want 2 cosecant. Isn't 2 over sine the same thing as 2 cosecant? Because okay, I want you to understand. Now, you don't have to show me this. I just want you to understand why. Isn't 2 over sine the same thing as 2 times 1 over sine theta? Y'all understand that? If I had 2 over sine theta, that's the same thing as 2 times 1 over sine. Isn't 1 over sine a reciprocal? So I could rewrite that as 2 over 2 cosecant theta. And that is what I wanted. Does that make sense? Stop me if it doesn't, okay? Stop. Is that what you tell me? Let me go to the store and change it. I'm about to turn the temperature now. Why don't y'all, okay, number 16 was pretty easy. Do I need to work 16?
No.
I want you to try 17 right now, the one you didn't do for homework. We're going to talk about it. I want you to do 17 right now. While I go check that temperature. And you may work together in your group if you get stuck. That's what I figured. I went in there and said 71. I said, it feels harder than 71.
No, my house is like 73.
Holy crap, I'm just
Like, I keep my house on 69 even in the winter time. Like, 70 is too hot for me.
67.
What now? But it's cooler in the room next door, and it's more control here. I said number 17. But at the end do it, okay. $17, you will have to find a common denominator. What I would do is do a common denominator. What's the common denominator? Between 1 plus cosecant and cotangent. You can't make that all of it. Yes, so you need to multiply this by cotangent, this by cotangent, cotangent squared. This times this, because you have that other cotangent squared. Erase all this, I need to erase it. You're not mathematically doing it illegal. You need to write it and let me come back and show it to you. Okay, let's do a common denominator. You can't make this become this and this. So you have to settle for both of them. So your common denominator would be cotangent theta times 1 plus cosecant theta. Alright, let me help you. Let me get you started here. Alright. Number 17. Cotangent theta over 1 plus cosecant theta plus 1 plus cosecant theta equals 2 secant theta. Okay. The first thing I would do, I see fractions, I'm going to find a common denominator. My common denominator for both of them would be cotangent theta times 1 plus cosecant theta. Cotangent theta times 1 plus cosecant theta. Okay. On this, I had to multiply this by cotangent. I had to multiply this by cotangent. Well, if I multiply the denominator, what's cotangent times cotangent? Cotangent squared. So I'm going to put cotangent squared there. Here, I had to multiply this side by 1 plus cosecant. So I'm going to have to multiply 1 plus cosecant times 1 plus cosecant. Now, will you have to FOIL that out? Yes. You can't just say 1 plus cosecant squared. So you need to go to the side and FOIL that out. One times 1 is 1. 1 times cosecant is cosecant theta. Cosecant theta times 1 is cosecant theta. Cosecant times cosecant is cosecant squared theta. So that's going to be 1 plus 2 cosecant theta plus cosecant squared theta. So I'm going to put that in place of that. Cotangent squared theta plus, I'm going to write that, 1 plus 2 cosecant theta plus cosecant squared theta all over cotangent theta times 1 plus cosecant theta. Now, you might be thinking, so Mr. Fisher, I see an identity in that top part, but it's only part of it. Can I substitute that in for just that part of it? Yes, because what should stand out to you in that numerator right now? Cotangent squared plus 1. So what can I put in place of that? Cosecant squared theta. So in place of this, I put this. Now, I'm going to combine my right terms. That's a cosecant squared and a cosecant squared gives me 2 cosecant squared theta plus 2 cosecant squared theta. Like I said, I'm not going to mess with the bottom until I absolutely have to. Now, the numerator. What do you think, what is going around in your head right now with the numerator? I always look back in your toolkits. What somebody said is factor. It has a 2 in common and a what in common? Cosecant. So I'm going to factor out a 2 cosecant. Okay, that 2 is gone. I had 2. I took 1 off, so I'm just going to leave a cosecant. Plus 1. Oh, something beautiful is about to happen here. What can you do as cosecant theta plus 1 and 1 plus cosecant theta? Cancel. You said, Mr. Fisher, they don't look exactly right, but isn't addition commutative? Now, if that was subtraction, could you easily do that? No. But that's addition. And that means the same thing, so I cancel those out. Oh, it's looking a whole lot better, isn't it? I'm down to 2 cosecant over cotangent. Now, this is when I will start breaking things down to sine and cosine. Okay? Breaking things down to sine and cosine. Okay, so 2 cosecant would be 2 over sine divided by cosine theta over sine, because that is what cotangent is equal to. Cosecant is 2 over sine. Cotangent is cosine over sine. So I'm going to rewrite that. 2 over sine theta divided by cosine theta over sine. 2 over sine theta times, flip it. Your sines cancel out. And I'm left with 2 over cosine. Well, can I write 2 over cosine as 2 secant? That's what I wanted. And I want to prove that it's equal to 2 secant. So 2 over cosine, that equals 2 secant theta. And that's what I wanted. Isn't that beautiful? You will have one like that. That's the hardest, that's the longest and hardest time I will give you. And you will have one like that. So, but it's not, you just got to keep breaking it down. It's like a mystery. Yes?
Can you move it up? I'm trying to get some of it up. Okay.
That's why I didn't give you this one in homework last night.
How many points did I work on?
There's 12 on your test, so 8 points apiece.
So that's on, that one's only worth 8 points?
They're all worth 8 points on your test. You got 12 next Tuesday. It's not hard. Don't give up on it. You got to keep just looking at it.
How did you take the one out?
I'll take the what out.
So, you see where you start?
Right here?
No, where
Okay, cotangent squared plus 1. That is why we had a test. If you do not, if these do not come natural to you, you're going to struggle. Okay? So, I replace that with cosecant squared. Then I combine my right terms. That's 2 cosecant squared. Well, then I have to keep, okay, you have to know these by heart. You got to have these in the back of the mind. I saw factoring. Let me try to take a 2 cosecant out, which I did. And that left cosecant theta plus 1. Well, these are the same term. Cancel them out. Then I just reduced that to sine and cosine and went from there. Yes, you may. All right, let's look at number 18. On number 18, which side would you start with, Derek? Left or right? Okay, and I'm just going to start. Okay, there's no need to find a common denominator. There's no fractions. I don't see any Pythagorean identities right now. I can't factor. There's no multiplying, so I'm just going to start reducing. Sine. Well, let's see here. I'm not going to factor here because what I'm hoping occurs. You see it cosine squared? Now you might can get the same thing. If it's mathematical correct, it's fine. Because I'm trying to get one of those Pythagorean identities. I'm going to leave cosine square alone. But we will look at it in just a minute and see how we can do it, okay? Okay, so sine times cosine, sine over cosine. These cosines cancel out. I'm left with sine squared x plus cosine squared x. What is that equal to? 1. You can do it that way. Let me see. Did you factor, hon? Okay, let's see. We're going to try it a different way. That's one way. I'm going to factor out a cosine. I'm left with sine x times tangent of x plus cosine x. Okay, so we got sine, and break tangent down to sine over cosine plus cosine x. That leaves me sine squared x over cosine x plus cosine x. I'm going to find a common denominator, which is cosine. If I multiply that by, I'm going to multiply the top by cosine squared x. Sine squared plus cosine squared is 1. Those cancel out and you get 1. So you could do it that way or the other way. It's fine. It does work. All right, let's turn to page 2 in your notes. I'm going to do 3 more. Okay, number 17 is an interesting one, okay? And I'm going to teach you to think like this. All right. Which side do you want to start with? Left or right? Does not matter. Left, okay. Either way, you're going to come up with it. Now, I would never be mean to give you one like this for all of it. Just think like this. I see tangent squared plus 6 equals secant squared x plus 5. Tangent and secant is related in a Pythagorean identity, aren't they? Okay? Watch this. I'm going to take this identity if I move this over here, that would be tangent would be equal to secant squared minus 1. Do you see that? I'm going to take this and plug this in. What's negative 1 plus 6? Is that what I wanted to prove? Tangent and secant are related by this identity. I took this 1 over, and I get secant squared x minus 1. I see a secant over here. If I'm trying to prove it's equal to that, I said, okay, tangent squared and secant squared is related in identity. So I solved this one for tangent. I took that quantity and put it in place of that. Secant squared x minus 1 plus 6. Okay? So everybody paying attention, please look up here. Negative 1 plus 6 is positive 5. Well, that's what I wanted to prove, wasn't it? Now, you could have went this way. Let's say we start on this right here. Secant squared x. Could I have solved, could I have put this in place of that? That would have been tangent squared x plus 1 plus 5. Well, that would have gave me tangent squared plus 6. I would have proved it, wouldn't I? Does that make sense? I don't give you many or any like that, but I'm just saying that's how you would prove that one. How do you get out of that? Never mind. Thank you. All right, let's look at 18. Now, on this one right here, the left side looks more complicated. Now, I want to ask you something. If I had tangent next to cotangent and multiplied them, what would that equal? 1. If I had secant next to cosine, multiply, that would give you. If I had sine next to cosine, it would give you what? You need to be able to recognize that, okay? Because they are reciprocals of each other, and the product of reciprocals is 1. So right here, this should just shout out to you. Tangent and cotangent would be what? Okay, 1 minus cosine squared theta. Now what shouts out to you on this one? Which identity? The first one. So I got sine squared theta plus cosine squared theta equals 1. If I wanted to see this, I would just move this over, wouldn't I? So what's that equal to? And is that what I wanted? Is that what I wanted? Yeah. So that's my proof. Are we good? Let's stop there. You've had enough for today. All right. Your homework is page 7, 27 to 37. Tomorrow, all we're going to do is go over them, and you're going to do something in class practice. You won't have any homework tomorrow night. Okay? But tonight, these are just very general lists. When they are, because I can manipulate that tag right here. That's what I did. Don't do that too. Don't have it on both sides. That's letting me know. Guys, I want you to notice something. It's all about some format issues. The format, do you see, like on this, let's say this problem right here. I started left and I just did equals. I didn't put anything on the right to the very end when I proved it. Does that make sense? That's the format I want on your paper, okay? Yes. Like here, I did not put anything on the right till I got to the very end and boxed in. That's the format I want, okay? Yes. I need some steps though.